Good morning, gentlemen. Today is Tuesday, May the 12th, and today I am going to talk to you a little bit about ocean tides. Now, why does this tie into chapter 13? Well, the tides in the ocean are actually caused by the force of gravity, right? Believe it or not, the entire ocean is being pulled by the gravitational pull of not only the moon, but also of the sun. But we'll get to that in just a moment. If you've ever lived near the seashore, right? I grew up on Long Island, and so spent many of my summers on the beaches. But you'll know that every 12 hours or so, you experience what's called a high tide, where the level of the water is very high. And then 6 hours later, you experience low tide, where the level of the water is much lower, and there's a lot more sand on the beach, if you will. So what actually causes this? Well, it was actually Joe Newton who demonstrated that the ocean tides are caused by differences in the gravitational pull of the moon on opposite sides of the Earth. This is a great little diagram, and it shows you the relative positions of the Earth here and the moon here. And notice that wherever the moon is, that's where we experience a high tide on our location on the Earth. So somebody standing on the beach on this side of the Earth is going to experience a high tide. Whoops. Sorry. What is going on? There we go. And somebody on the other side of the Earth at the same time is going to experience the high tide as well. And so that would be right here. Okay. Now, people on the in this picture on the top and bottom of the Earth at that point would be experiencing a low tide. Now, remember that the moon is moving in a circular path around the Earth. And so 6 hours from now, 6 hours ish, the moon is going to be located about here. And so this point will experience a high tide, and this point will experience a low tide. Okay. And so essentially the movement of this bubble of water around the Earth is due to the pull of the moon's gravitational field on all of that water. And so again, every 6 hours or so, you experience high tide, then low, then high, then low. So 4 ultimate tides at each time, or each 24-hour period or so. Now, so again, Newton showed that the ocean tides are caused by differences in the gravitational pull of the moon on opposite sides of the Earth. All right. So here, all right, all of this water is being pulled toward the moon, and so that makes a bubble. Okay, and of course, on the quarter sides, you end up with a flattening area here. All right, and again, there's 2 tides a day, 2 high tides a day, because the Earth is rotating on its axis, and that causes 2 bulges in the oceans, and one is near the moon, and the other is on the opposite side of the world. Okay, and remember, the Earth is spinning around its axis, and so that high tide follows the spin of the Earth and is always pointed toward the moon, and of course on the opposite side of the world as well. Now, the sun is also somewhat responsible for the production of ocean tides. Remember, the sun has a huge mass compared to the mass of the moon or the mass of the Earth. And so, although the moon is much closer and therefore has a much greater effect on the Earth's ocean tides, the sun still plays a role in some of this. All right. If you look very carefully at this diagram, we've got the Earth right here in the middle and the moon in 4 different locations. So if the moon was located here, we'd call it the new moon, because we'd be looking at the dark side of the moon. here's the first quarter moon, full moon when it's on the opposite side, because the sun rays are hitting the moon. We can see the light side of the moon. And then over here is the last quarter. Now, the position of the sun is also very important in terms of the location of the high tides, because it has an additive effect with the moon's gravity. All right, it turns out that if the sun and the moon and the earth are all lined up, then we have really, really high tides and really, really low tides. All right. So in the position of the new moon and the full moon, we would have what we call a spring tide. This occurs because, for example, in the case of the new moon, both the sun and the moon are pulling the oceans away from the earth. And so you have a really, really high tide there. And on the quarter sides of the earth, you've got really, really low tides. And we call that, the position of the new moon or the position of the full moon, what we call a spring tide. And so those happen twice a month. All right. Twice a month, we have spring tides. Now, we also, twice a month, have what we call neap tides. And these are when the sun and the moon and the earth are all at right angles to one another. So in other words, the sun is pulling in one direction and the moon is pulling at a direction 90 degrees away from the direction of the sun. And we call that a neap tide, N-E-A-P, neap tide. And so a neap tide is when we have a very low high tide. All right, think about what I just said there. A very low high tide and a very high low tide. In other words, there's not that much movement in the water, in and out of the beaches. Whereas in a spring tide situation, there's a tremendous difference in terms of the water level between the high tide and the low tide. At the neap tide, there's just a little bit of movement of the water during the actual tides. All right. So in a spring tide, you have a very high tide and a very low tide. And this is again because the sun, the moon, and the earth are all lined up. During a neap tide, on the other hand, you have a very low high tide and a very high low tide. All right, I know the use of the words high and low here can get a little bit confusing, but if you read it carefully and think about what we're saying here, it should make sense to you, I hope. All right, and a neap tide, of course, occurs when the sun and the moon and the earth are at right angles to one another, and therefore the gravitational pull of the sun is in a different direction as the gravitational pull of the moon on the earth's oceans. Okay, all right. That brings us to example number 6. All right, the question here is this. We know that both the moon and the sun produce our ocean tides. And we know that the moon plays a greater role because it's closer. Does its closeness mean that it pulls with more gravitational force than the sun on the Earth's oceans? And the answer here, if you think about it a little bit, is actually no. And the reason for that is because the mass of the sun is orders of magnitudes greater than the mass of the earth or the moon. And so therefore, the sun still plays a huge role on the ocean tides, and a huge role. And so you have to really take that into account when you're talking about the tides and when they're coming in, when it's going to be a spring tide, a neap tide, and all of that kind of stuff. All right. And so the answer here, again, is that the sun's pull is still much, much stronger than the moon's. All right. Okay. Now, one other interesting aspect to the position of the sun and the moon in the sky, if you will, is that sometimes they overshadow one another. All right. And we call these instances eclipses. Now, there are two different kinds of eclipses. All right. You can have what's called a lunar eclipse, which is when the moon kind of disappears or is overshadowed in the sky. And you can also have a solar eclipse where the sun is eclipsed and kind of is overshadowed in the sky. Now, this is all, of course, due to your perspective, our perspective, standing on the Earth. All right. In a lunar eclipse, what that means is that the moon disappears. Well, what's overshadowing, whose shadow is covering up the moon? Well, it turns out that that is the Earth's shadow. All right, the top diagram here shows what happens in a lunar eclipse. The light from the sun shines on the Earth, and there's an area here which is called the umbra, UMBRA. I know it's hard to read on this slide. And that's a very, very dark shadow because the Earth is literally right in the way of the sun's rays toward the moon. And so in the umbra, the moon completely disappears. All right, it's completely overshadowed by the shadow of the Earth. Now, if the moon was in this area up here or this area down here, there's a partial eclipse because it's we call that the pre-umbra.
It's 9 o'clock.
And this is an area where some light from the sun hits the moon, but not very much. Now, on the other hand, down here, you see the scenario for a what we call a solar eclipse. Now, this isn't nearly as dramatic and it nearly as widespread because the solar eclipse is only seen at a very small point on the Earth. So again, this time it's the shadow of the moon being pushed onto the Earth. So here's the rays of the sun coming and striking the Earth and lighting up half of the Earth at a time. But if the moon's in the way here, then there's a point on the Earth that's in the shadow of the moon. And so what appears to happen is in the sky, the sun will be blotted out by the moon. And again, if you're directly in that shadow, you're in what we call the umbra. And if you're not directly in it, but you can still see the shadowing, you're in the penumbra. Okay, PENUMBRA. All right, and so that's a solar eclipse when the moon is directly between the sun and the Earth. All right, gentlemen, that is our discussion for today. Have a great day. There will be an assignment, the worksheet 13.1. I do have to actually go into LaSalle and scan that into the machine, so that may not appear right away. If you're on this video right now and looking at it and you don't see the worksheet posted yet, please come back soon and look for that. All right? And that will be due on Thursday of this week. All right? All right, gentlemen, have a great day, and I will see you soon.